Hello guys. So our next problem is that we need to design and implement LRU cache. We need to design and implement LRU cache. The operation that we support in this LRU cache is that put, get, and print. Put inserts the value into the cache. Get access the value from the cache. Print just prints the current cache elements. So this is how the put, get, and print operations should work. This is not a solution. This is just the requirement of put, get, and print how they should work. We will see the example of these elements coming into cache uh, with the put example. Get and print are very straightforward. Okay, let's see how LRU cache works with these elements that are coming into the cache. So let's say that initial capacity of the cache is given as 3. Okay, this is the current cache. Current cache, always we have current cache, and this is the current capacity we have. Initially we have current initially there are no elements in cache, capacity is 0, and we have a cache as empty. Let's say that the first element we're getting is 7, so we call put on 7. We are checking that is 7 in cache. Initially cache is empty, then it's not, so we come to else. Then we check if cache is full. Is cache is full? No. What is full means is current capacity of the cache is equal to the given capacity. No, because it's just 0. So then what do? We just go insert 7 into the cache. Just go insert 7 into the cache. Now 7 is done. Then next we call put on 0. Then what do? We check that is 0 in cache. No. We check that is 0 in cache. No. Then next what we check is cache is full. No. Sorry. Initially when we inserted 7, the capacity of the cache became 1. Is cache is full? No. Then what do? We just go on insert 0. Insert 0. Okay. The next step, now 0 is done. We update the capacity of the cache to 2. So next we receive the element is 1. So then we check, is 1 in cache? No. Is cache is full? No, because still capacity is 2. Then we just go insert 1 here. We just go on insert 1 here. Okay. And then we increment the capacity to 3. Next we receive 2. Now we'll go and check, is 2 in cache? No. So we have only 701. Next, is cache is full? Yes, because the capacity and this capacity is reached equal to 3. Then what do? We remove the oldest entry. What is the oldest entry here? 7, isn't it? So we received 7 for 0, 1. So the first element we removed. We removed the oldest entry and we insert 2 here. We insert 2. Okay. So we just keep the capacity as a 3 here because we have only 3 elements. We remove the oldest entry, right? So next element we receive is 0. We call put on 0. We check that is 0 in cache. Yes, we have 0 in cache. If 0 in cache, what do? We only do that, we update its position. What is meaning of update its position? We changes its position from the oldest to the newest. Oldest to the newest. That means if you would have understood that right side we have the newest entries, least recently used, and the left side we have the oldest entries. Okay, let's see how it works. Now do we have to update its size? No, we just, because it's already presented, we moved one element from here to here, so we don't need to update any capacity. Okay, so now 0 is also done. Now let's see, let's call put on 3. Let's call put on 3. So then we check that is 3 in cache. No, 3 is not in cache. Then what do? We check, is cache full? Yes, cache is full. What do? We remove oldest entry. What is oldest entry? Yes, is 1. Then we'll go, after that we just go and insert 3. And we don't have to update the current capacity, and 3 is done. And next we call put on 0. Again, we'll check that is 0 in cache. Yes, 0 is in cache here. So we update its position. What do you mean update the position? Wherever it is, from that position to the least recently used position, because we accessed 0 recently. That's how the LRU cache should work. And that's it, we are done. Let's say that now we'll call put on 4. So is 4 in cache? No. What do? We check that is cache is full. Yes, because capacity is 3. Then what do? We remove the oldest entry, that is 2. We'll put 4 here. Okay, we put 4 here. And it's done. Now we call 2. Then we check, is 2 in cache? No. What do we do? If 2 is not in cache, we check that is cache is full. Yes. Then we remove the oldest entry and we just put 2. Insert 2 here. Next, we just call 3. 3 on put. So we check again. Is 3 is in cache? No. Is cache is full? Yes. So we remove the oldest entry. We insert 3. Okay. So this is how the put works. So probably, I mean, I think you would have understood. We don't have to go through all the remaining entries. So how the get should work? Whenever I access the get, what it should return is the element wherever it is located, and also it's update its position again. Update its position. Let's say that I want to call now get on. I want to call get on 0. Get on 0. What happens if I do get on 0? There is no element in get, so we don't have to do anything. If k is in cache, is 0. If you see here, is 0 in cache? No, we don't have to do anything. Let's say that now next I want to call get on 2. If I call get on 2, what happens? Then we see that is 0 in cache. Yes. Then what do I do? I just update its position. I update its position from here to here. Now we are good. Now the last operation is print. Print means we always need to print the cache elements in the least recently used order. So whenever I call print, I should print the cache in this order. That means that I should print 2, 3, 4, not 4, 3, 2. Okay. So this is how LRU cache should work. In our next video, we will see how to implement this. Thank you.